L of x, so this is x, C of x, and L of x. L of x here is 1, and in these cases is 2. So if I sum over all possibilities, let's take the second extension here, so k equals 2. I have 9 possibilities, AA, AB, AC, BA, BB, BC, CA, CB, CC. So if k were 2, I would be summing over all of these. These are all possible twofold vectors of my source symbols. The lengths of the extended code words would be what? Well, AA is 0, 0. AB is 0, 1, 0. AC is 0, 1, 1. BA is 1, 0, 0. BB, 1, 0, 1, 0. BC, 1, 0, 1, 1. CA, 1, 1, 0. CB, 1, 1, 1, 0. CC, 1, 1, 1, 1. So the length of the extension here, well, this is just AA, 1 plus 1 is 2. 1 plus 2 is 3, and so on. So basically I'm summing up, in order to get the length of the extension, I'm summing up the lengths of the original code words. That's 1 and 1, 1 and 2, 1 and 2, 2 and 1, and so on. So if I want the length of the extension, it's basically this. It's the sum of all the components.
Sorry, what was the discussion about the summation over all k variables being into one? I couldn't get that. Just the thing
say it again, please.
You said all these k variables, summation,
Yeah.
the sequence of summations. I couldn't get the idea how you made it into one vector value summation like this. The thing you explained recently.
So I'm summing over all the k. These are, so I have a vector, x1, x2, x3, and so on, up to xk of source symbols. I'm summing over all of those variables. So therefore, this is the sum over all possible k-fold vectors of the source symbols. So what's the, if I take this and I encode it using the extension.
So this, sorry for interruption, that is the cross product of, like, that's the all possible sequences.
Yes.
So they are vector valued.
Yes.
Okay.
And this is the length, all possible lengths of the encodings of these. So the encoding of this is Lx1 plus Lx2 plus, and so on, up to Lxk. This is the extended code word, right? The extended code word is I just take x1 and substitute cx1. I take x2 and I substitute cx2. So the length of that extended code word is just the sum of the individual lengths of these code words.
So in this long summation, only one variable was changing at a time. You made it into a whole vector summation, a vector variable summation, and used
So,
vector variable.
Yeah, I mean, you can think of it as I sum over x1 and then I sum over x2, but in order to sum over x1, I need to fix x2 through xk for all possible values.
Only
so
one has to change at a time.
That's right. So here I'm just summing over, I'm just making it more compact, that's all.
Thank you.
Okay. So what is this? Sum over xk, 2 to the minus L xk. I mean, L xk can take values from 1 up to, let's say, L max. So there's some maximum code word length. So I can change the summation into sum from I equals 1 to L max of 2 to the minus I times the number of times the 2 to the minus I occurs in this sum. So basically, I'm now going to rearrange the sum. A lot of these terms will be repeated. So for instance, there will be certain code words of length 5. So in this sum, I'm going to rearrange the sum in terms of the length as opposed to the code word. So that basically this will be equal to the sum over all possible lengths, 2 to the minus I, times the number of code words with that length. So let AI be the number of code words with length I. And then I get this. All I'm doing here is I'm taking all of the possible exponents and grouping them together. So the exponents can range from 1 to L max, where L max is the maximum length of any possible code word in this code. So I'm going to group all of the terms with the same exponent together and just count them up, and that counts what appears here. So we know that the extension is non-singular. This is the extension, the kth extension of the code word. So we know that. What does that imply? That implies something about AI. If the extension is non-singular, then AI is the number of code words of length I. Being non-singular means that there has to be enough code words so that they can all be unique. So what's the maximum number of code words of length I? In other words, what's the maximum number of binary sequences of length I?
The power set.
Yes, it's 2 to the I. That follows from this. Let's say A was greater than 2 to the I. Then there would have to be 2 code words that were the same. It's the pigeonhole principle, really. So if AI was greater than 2 to the I, AI is the number of code words of length I. If AI was greater than 2 to the I, then the extension could not be non-singular because there would have to be two code words that were the same. So this implies that AI has to be less than or equal to 2 to the I. Let me write my first statement up here. Sum over x 2 to the minus lx to the k is equal to this. This was just my first statement. I showed that this was equal to that by the derivation we had over here, and then I just rephrased that into this. So, what this implies, what this taken together with this implies, is that sum over x, 2 to the minus L of x to the k, is equal to sum from I equals 1 to L max of AI 2 to the minus I, which is less than or equal to sum over I equals 1 to L max of 2 to the I, 2 to the minus I, which is equal to L max.